Hello friends, welcome to the video number 19 for the Python 3 series. And well, in this video we're gonna be talking about sets and frozen sets. Now this is probably gonna be a little bit long video, but I don't wanna make again 2 or 3 videos like I did with lists. So actually what I want to show you, just in case you don't remember, you can always come here to the Python documentation or the Python manuals and consult, right? If you don't remember where it is, you can come here to the Windows Start button, scroll down in your programs, come to the letter P, so you should have here Python 3.7, and here it is, Python 3.7 manuals is the one with the yellow question mark. So just launch it, and you should see something like this. Now just come here to the search, type sets, hit enter, and just come to the very first one, built-in types, and you're gonna have to scroll quite a bit down. You can see here where I am until you finally reach set types, sets and frozen sets. So we're gonna be talking about a little bit or a little quick as fast as I can on some of these things that we can do with sets and frozen sets, and some other things that we can do only with sets that do not apply to frozen sets. And well, here we are seeing that sets are mutable, frozen sets are immutable, right? So the set can be changed, the frozen set cannot be changed. So depending what you want to do, you want to have the flexibility to change that set, just keep it a set. You want to make it final or froze. Well, you can froze that set by doing it a frozen set, so it cannot be changed. uh, so again, actually I'm gonna be uh, using this for this video. Just let me keep it here in my site. Okay, so from previous videos I have here my list, right? Is all these elements. And well, a set or a frozen set, just like tuples and lists, they are collections, a collection of items. And well, the way we define a list is by using these square brackets. The tuple is using these parentheses. Now remember, parentheses in tuples are optional. You can just leave them out, and actually what defines the tuple is the comma. But again, we said that for better view and clarity, we are going to be using the parentheses to say, okay, this is a tuple. And now to declare or to make a set, what we're going to be using is these curly braces. All right, so list, tuples, and sets, brackets or square brackets, parentheses, and braces or curly braces. And well, that's it. Now remember, if we print a list, like in this case, well, we get, of course, all the list. Now the particularity of a set is that it will return, whoop, uh, let's say a collection of unique items. So it's going to remove any duplicate items, and they are not returned in any particular order. Now in this case, we're gonna see in with numbers, it actually gave me like the sorted set, but we are gonna make some examples with letters, and you're gonna see that they are scrambled. Um, so again, the set is going to remove any repeat items, and it's gonna just give me the collection of unique items like we saw in here. Um, well, we're gonna use this later, probably not all of them, but just a few. Now, another way we can create a set, and actually this is something we can do with lists and tuples. I didn't saw that before, so probably in the next video we're gonna see pretty fast how to make conversions. But right now we're gonna see how we can convert a list to a set, and the only thing we need to do is say I'm gonna call this conversion. Is gonna be the name of my variable, because well, I'm gonna be converting that letter list, right, which is a list, to a set, and I only need to say set. You see that it turns purple. So it says just give me empty parentheses to create a new empty set, or you can give me any iterable. So we're gonna create the set with this iterable. In this case, I'm gonna pass the list, and I'm gonna print the conversion. So there it is. You can see I have the curly braces. So this is my list converted to a set, and it's now a set. Um, so now things that we can do with, oh, well, if I wanted a frozen set, well, I just need to do a frozen set, right? Save this, run it, and it tells me this is a frozen set. Okay, just to be able to differentiate between a set that can be changed and a frozen set that cannot be changed. So let's get back to the set, and here we can say what is the length of my set. Well, this is only 4, so it should be 4. There it is, 4. Now probably you remember we can say something like, I want to see if A is in my set that is stored in conversion. It says, okay, it's true, it is there. Again, we can say not in. So it's going to tell me it's false because, of course, A is inside of my set. And, well, this is where we're going to be using these examples. Probably just one. I'm going to try to make this simple because it's already almost 7 minutes. Uh, the examples that I'm going to be making now is to try to make an example of this. And this is probably one of the most important parts of sets. You can compare your sets to see if one is a subset of another, if it's a subset but not equal, right? Because sometimes it can tell you, okay, all these elements are inside of the other inside of the other set, but well, it turns out that it's the exact same set. So with this one, you can see if your set is lower, let's say it's part of the set or is the same set. But you can also say, okay, I just want to see if this is a part of a bigger set, but it's not equal, it's not the same set. So I hope this makes sense, right? It's can be a little bit confusing. Well, at least it is for me. Um but again, you can see if there is a union between two sets, right? Some repeated elements. There is an intersection. There is a difference, symmetric difference. You can copy. So let's just see a couple of examples with the subsets. Um, okay, so we're gonna use. I wanna see set one is a subset of my set, right? This is contained inside of this one, or all the elements in this set are inside of this other set. So it's gonna tell me true. If I do it the other way around, tells me it's false. But then I can say um, this is greater than, right? My set is a superset of set 1, and what it's gonna tell me is true. Okay, well, sorry, but again, I am against the clock in here. Let's go back to some things. Oh, these are some things that we can do with sets, but we cannot do with frozen sets because again, we're gonna be modifying the set. And what I'm gonna do here is I'm gonna do a conversion dot add, right? So we can add an element to a set. In this case, I have A, B, C, and D, so I want to add E. And well, then we're gonna print the conversion. So now I have B, A, D. Here is my E and C, right? Of course, again, if I try to do this with a frozen set, it tells me frozen set object has no attribute add, right? We cannot modify frozen sets. So there is my set, and now what I can do also is I can remove elements. In this case, I don't have a letter E, so I'm gonna have a key error, right? Now, errors are not necessarily a bad thing. Sometimes we're going to want to have something that tells me that something went wrong. Later, we're gonna talk about error handling, so we can use this in our advantage to get to display a message in our program saying, okay, you know what, you try to remove an element from a set, but that element is not inside of that set. Of course, we can say remove letter A, which I know it's whoa, I know it's in here. So now I see my set without the letter A. Now another way we can do this is instead of saying remove, we can use the discard. Discard A, and I get the same result. Again, you can see that these are in not any particular order, they are scrambled. Um, Now the difference between removing discard is that if I try to discard something that is not inside of the set, nothing is going to happen, right? We don't get an error. So again, depends on you. What do you want to do? If you just want to go on, if the element is not there, well, just continue. Just use the discard. But if you actually want to get an error, to know that the element is not inside of a set, and then do something with that error, you can use the remove. Um, we can use uh, the pop. Remember this? We use this in the lists. Now here it tells us that it's going to return an arbitrary set element, and let's do a pop, and then print the pop. So in this case, it popped the letter C, and I get it printed. Let's run it again. Now it popped the letter D, and we get it printed. So again, it's arbitrary, right? In the lists, it was by default it was the last element of the list, or we could specify an index to pop any other element. But in this case, again, as we just saw, it's gonna be something arbitrary. And last thing we're gonna be doing here is whoop, we're gonna do a conversion dot clear, right? So we can remove all the elements from the set. Remember, all these things we are doing is just for sets, not for frozen sets. Frozen sets cannot be changed. So we get the empty set. All right. And well, that's it for now. I think so. Already 13 minutes. But well, I hope that I was able to teach you something, a little bit about sets and frozen sets. And well, as always, I hope you find this video useful. So thanks all of you for watching. Please don't forget to subscribe to the channel. And well, see you on the next video.